Asteroid mining always runs into the same wall. You can't keep launching chemicals. Every kilogram you ship to space costs a fortune. And the moment your process demands on consumables, it stops being a space mining and more like space resupply. Now, what if your mining technology was closed loop, powered entirely by electricity, and the reagent you needed was basically just salt water and power? Today, I'm going to show you why SEM TECH is, in my view, the only path to asteroid mining that we've got, and how it sidesteps almost every "this will not work" argument in this literature. Welcome back. So if you're new here, SEM TECH is an ion exchange electrolysis mining platform designed around a continuous loop architecture. The whole point is to minimize consumables, avoid toxic waste streams by driving the chemistry with controlled electrochemical potentials. What matters for space? If your process is closed loop, you're not launching drums of acids, oxidizers, or reagents for resupply. Your only supply chain is power, which can be powered by nuclear reactors for centuries. The paper length focused on undifferentiated carbonaceous asteroids and makes a bunch of points that are totally fair. Firstly, asteroids are heterogeneous and geologically messy. Composition vary at small scales, and even water can be unevenly distributed. Analytical meteorite collection might not have a full representation of what's out there, and space weathering, impact processing can obscure bulk composition. If you're chasing resources like water, it can be hard to extract because it's often bound in hydrated minerals, which are very hard to traditionally deal with. So this paper is basically saying asteroid mining is promising, but the composition plus complexity problems are real. And when I read that, my reaction was, okay, these are exactly the kind of problems electrochemistry and closed-loop processing were born to solve. SEM TECH is designed to handle a broad dissolved metal chemistries and diverse feedstocks. It's been tested on Riemanning ore, tailings, harsh variable materials, including direct processes of high sulfide ore. So when this paper says asteroids are heterogeneous and mineralogy varies within the same parent body, cool, that's literally our feedstock for SEM TECH. Most asteroid mining concepts quietly assume you're bringing in a chemical plant's worth of inputs. SEM TECH's design philosophy is the opposite. Create the key chemistry in situ using electricity and a saltwater based source. This is ran through a continuous closed-loop architecture where the key acids and oxidizers like hydrochloric acid and chlorate oxidizers are generated in situ using electricity and brine. We don't need any resupply. There's no need. This study specifically flags that water can be difficult to extract because it's often bound within hydrated minerals. Here's the SEM TECH angle. Electrochemistry is the most economical and direct way to deal with that. We can split the hydrated minerals into water, further creating more leaching solution, and not only have a system that regenerates, but also producing more chemicals and even more units to go to other asteroids. Remember, all chemistry is based off electrons. If you can control which ions or elements go where with electricity, you fundamentally control chemistry at the most direct method possible. This isn't hype, it's pure science and the law of thermodynamics. My only competitor is the law of physics. The primary reason a lot of electrochemical separation ideas don't commercialize is simply the cost of the membranes. Commercial membranes cost over $100 for a small sheets. Meanwhile, our membranes cost less than $1 for a square yard. Additionally, our membranes are designed for improved resistance to fouling and acid attack, which is critical to perform in these harsh acidic mining conditions. So, knowing all this, our only limitation is power. And we kick bubblegum with that too. Our system's early estimates for terrestrial ore were at the order of 300 to 2,000 kilowatt hours per ton, with a large margin of error, corresponding to as low as $50 a ton in stated electricity costs at 50 cents a kilowatt hour. Of course, in space using nuclear power, the cost of energy isn't an issue, but a micronuclear reactor that is the size of a shipping container can produce up to 20 megawatts of electricity. That is 20,000 kilowatts. So one of these small nuclear reactors can process up to 60 tons in a single hour, almost 1,500 tons per day. With estimates of 3.5 ounces of platinum group metals per ton in an asteroid, That gives us a profit of $11.5 million per day from a unit the size of 2 or 3 shipping containers. Easily can fit in a single Starship rocket. The paper is centered on carbonaceous chondrites, carbon-rich bodies, and their potential value. And here's where the point is strategically important. Carbon-rich asteroids aren't just ore, they're also potential feedstocks for propellant and manufacturing, which could support continuous shipment of material, especially if the rest of your industrial chain can operate with minimal imported consumables. Once we have a closed-loop processing center that produces metal powders and concentrates, you're not just mining, you're building an off-world supply chain. So, a recap. Here's some points from the study and a direct response. Asteroids are heterogeneous. SEM TECH handles the diverse feedstocks and broad chemistries. Meteorites might not represent whole asteroids. Well, if you can process a wide range of inputs, you reduce dependencies on perfect target predictions. Water is bound in hydrated minerals, and they're hard to extract. Electrochemical control enables the most easiest and economical way to split it into water. We need better in-situ verification and exploration. Our modular tunable process reduces the penalty of imperfect upfront characterization. Now, to be clear, there are 2 problems that SEM TECH doesn't fix. Firstly, robotics and low gravity. Handling regolith, crushing rock, managing fluids and solids, anchoring the equipment. This is hard, but it's an engineering maturity problem, not a chemistry or a new technology problem. In fact, there are many manufacturing advantages to zero gravity manufacturing without any atmosphere. And secondly, legal framework and regulations. The paper does straight up point out that we need international policies to regulate exploration and utilization sustainably and equally. But this isn't a technical barrier, it's politics. But sorry guys, we can't solve everything with SEM TECH, especially that one. Now, here's the part where people expect me to say that asteroid mining is the future. But I'm about to say the opposite. Do you believe that we need asteroid mining? No. Because my favorite study out of 2025 is out of the Colorado School of Mines. And it found that byproduct recovery from existing US mines could drastically reduce import reliance. Simply 90% of recovery could meet all US critical mineral needs. Yet our technology has 99% recovery. So not only do we not need to look up at space, we don't even need to dig a single new shovel into the ground. With SEM TECH, we can focus on cleaning up existing waste, recovering what's already there, and turning the environmental liabilities into resources. Utilizing our closed-loop electrochemical approach is designed to minimize consumables and eliminate toxic waste. And I hope this makes it obvious why I think this technology is critical and why I'm open sourcing it. If you have any questions or are curious about other applications, please feel free to drop a comment, and I can't stress this enough that it is going to change the entire global industry. Please subscribe, watch the next video. See you later.